once again to our YouTube channel. Thanks for subscribing to our channel. Really appreciate it. Today we quickly want to look at a particular topic in chemistry, which is actually a sequel to what we've done in the past, talking about organic chemistry. We treated organic chemistry in one of the previous episodes, and we talked about hydrocarbons specifically. And we made clear in that particular video that hydrocarbons are substances or compounds that are made up of carbon and hydrogen, basically. And so from that, we were able to explain to us that these hydrocarbons are made up of the aromatic hydrocarbons as well as the aliphatic hydrocarbons. And the aromatic hydrocarbons are substances that are found in ring forms, while the aliphatic substances would be cyclic or acyclic compounds. We went further to talk specifically about the acyclic components, where we said that they could be saturated or unsaturated. So today we want to delve more into the saturated hydrocarbons, which is actually what we refer to as the alkanes. So that is where we want to dwell today, talking about the alkanes. Alkanes. So what do we refer to as alkanes? Alkanes are chemical substances that we have talked about. They are organic components that are made up of majorly hydrogen and carbon, like we have been talking about, since they are also hydrocarbons. Saturated aliphatic compounds that are made up of, we have hydrogen and carbon. Hydrogen and carbon. These substances, the alkanes, have the general molecular formula, of CnH2n plus 2. Yes, that is the general molecular formula of the alkane components. The general molecular formula is CnH2n plus 2, where our N is an integer that could be any numeral. It could be 1 and upwards. It could be 1 and more than 1. So that is basically what the alkanes are. We have them to be Cn. The general molecular formula is CnH2n plus 1. So we said particularly in that video that alkanes are substances, they are saturated substances, basically because they possess a single bond. These substances possess a single bond. That is why we refer to them as saturated hydrocompounds. So talking about this now, we have so many members of this series, and they all follow the same molecular formula. All members of this homologous series called the alkanes, they all follow the same general molecular formula, which is the CnH2n plus 2. So looking at it now, if we look far back, if we go to the previous episodes, we talked about some properties of the carbon, where we made mention of a few of them, talking about carbon forming what we refer to as catenation, where a single carbon is tetrahedrally bonded to other substances, but significantly either carbon or hydrogen. It is tetrahedrally bonded. It has 4 bonds. That is why we are seeing it looking like this. So all of the 4 bonds now could be carrying hydrogen atom across it like this. Like we are seeing, it will be carrying hydrogen atom, or it will be bonded to another carbon atom, but it is a must that all of the carbon atoms must have a total of 4 bonds. And this is as a result of the fact that carbon compounds have 4 valence electrons. So it is with the 4 valence electrons that it goes into combination, and that is what we refer to as catenation. Another key property of the hydrocarbons that we will be talking about, the fact that we will be looking at what we refer to as, so this one is number 1, we'll be talking about another one which is called isomerism. Isomerism, and this is actually a phenomenon where a particular compound can exist in more than one structural formulas. It can exist in more than one way, to be drawn out in more than one system. So we'll be using majorly these two properties of the carbon and the hydrocarbon to say a few things about what the alkanes are. So to help us understand what we have talking about catenation and isomerism, to help us understand this better, we will quickly look at a few of the members of the alkane series. So let us start with the first one, which actually is the methane. We start with 1, where our N is 1. If our N is 1, we said we have CnH2n plus 2. That is the general molecular formula. So when our N is 1, we just invariably put our N to be 1. So that will give us this to be C1 H2 into bracket 1 plus 2. So that will be C1 H2 times 1, 2 plus 2. And that will eventually give us our C. Since it is 1, we can do away with that. And then H2 plus 2 will give us 4. So the first member series of the alkane series is the CH4. Now I want to draw this like we just showed us the catenation of a compound. Since it is just one carbon atom, the carbon atom will look like this. We have it looking like this, and it will be having the 4 bonds around it, such that it is surrounded with hydrogen atoms. Hydrogen, 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 hydrogen. So that is what the first member series look like. And then talking about the second one, we have where the N equal to. So we have Cn H2n plus 2. So it becomes C2 H2 into bracket 2 plus 2. So we have it to be C2 H2 times 2, 4 plus 2. And then that gives us C2 H2 plus 4, 6. So that is the second member series of the alkane family. So when we want to draw this, we have 2 carbon atoms. So we draw out our carbon atoms first, and they will be connected with 1 bond. And remember, when we talked about catenation as one of the properties of carbon atoms, we said it has 4 bonds. So each of these carbon atoms have been connected to one another with 1 bond, so they can each carry 3 other bonds. So we have this now, where we have 1, 2, 3, and this one also 1, 2, 3. So this is what we refer to as the second member series. For this one, the name is methane. Methane is the name of this one, and for this one, the name is ethane. Ethane. If you see now, they are both having a characteristic symbol of the name of the homologous series, which is alkane. They end with A-N-E. A-N-E. So that is it. And then looking at the third one, we have it to be CnH2n plus 2. That is the general molecular formula. So when our N is 3, here we have our N to be 2. Here when our N equals 3, so it becomes C3 H2 into bracket 3 plus 2. So it becomes C3 H2 times 3 is 6 plus 2. So C3 H6 plus 2 gives us 8. So the structure will look like this: carbon to carbon to carbon, and they are all connected to one another. Now the first carbon atom here, our carbon 1, you can see it, is just here. Let me put this. The carbon 1, this is carbon 2, and this one here is carbon 3. So we have carbon 1, carbon 2, carbon 3. Our carbon 1 currently has just one bond. It is connected to carbon 2. So that means this particular carbon atom can carry 3 other bonds. Here we have hydrogen, hydrogen, hydrogen. But look at carbon 2. Carbon 2 currently is already carrying 2 bonds. You see that it's connected to this carbon atom. It is connected to carbon 1 with this bond here, while it is connected to carbon 3 with this second bond here. That means it is already using 2 bonds of the 4 bonds that it can have. So that means it's having 2 other bonds, hydrogen here and hydrogen here. And this last carbon atom is just carrying 1 bond which connects it to the carbon 2. So that means it can carry 3 other bonds. So we have hydrogen, hydrogen, hydrogen. So this particular structure here is what we refer to as the propane. Propane. We can see that it's also carrying the same what? The same characteristic symbol of the homologous series name. So these are the first 3 members of the homologous series of alkane. We have the methane, the ethane, and the propane. Now, if you look closely, you will discover that the 3 of them are having straight chains. Well, this one is just a symbol, while this one's the ethane and the propane, they are all with straight chain hydrocarbons. But when we start talking about the 4th member series and then moving upwards, we will come to realize that there is a possibility of the structure being drawn as a straight chain hydrocarbon or a straight chain alkane, and it could also be drawn as a branched chain substance. So let us see. When we have our N to be 4, when our N is 4, we have it to be CnH2n plus 2. So we have C4, H2 into bracket 4 plus 2. So we say it's C4, H2 times 4, 8 plus 2. So that gives us C4H10. So C4H10 is the molecular formula of the 4th member series of the alkane family. So the name of this particular structure is what we refer to as what? As the butane. Butane, you can see also having the ANE. Now, structurally, how can we draw this substance? The substance having 4 carbon atoms and 10 hydrogen atoms. So let us look at, I said that we'll be looking at isomerism here now, where we will be drawing the structure of this particular molecular formula C4H10 in multiple ways, in having different structural formulas. So the first one where we want to talk about, we have this one here, where we have it to be the straight chain hydrocarbon. Carbon, 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 carbon. So we see now we have carbon 1, carbon 2, carbon 3, and carbon 4. And all of the carbon atoms are what? They are connected to one another. So on our carbon 1, it is currently carrying 1 bond, so it can carry 3 other bonds, and that gives it is what? Is 3 hydrogen atoms. Carbon 2 is carrying 2 bonds already. It is connected to carbon 1 and connected to carbon 3. So that gives it 2 other bonds. Hydrogen, hydrogen. Same with carbon 3. The same thing that is happening to carbon 2 is what is happening to carbon 3. It's currently carrying 2 bonds, so it can carry 2 other bonds. So we have hydrogen here, and carbon 4 is carrying 1 bond currently, so it is carrying 3 other bonds now. We have hydrogen, hydrogen, hydrogen. So with this now, we have drawn our 4 carbon atoms and the 10 hydrogen atoms around it. Let's start counting the hydrogen from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that gives us our carbon 4 and H10. So that is the name of the substance, butane. So this one here is actually called the butane. That is the straight chain hydrocarbon for this molecular formula C4H10. But it could be drawn in another form where we could be having it to be a branched chain substance. So let us see. When we have it looking like this, and then it is having this. Carbon 1, carbon 2, carbon 3, and we have another carbon here. Now, we will be having it looking like this. Okay, let's explain. We have this first carbon here carrying, just originally, it is carrying 1 bond connected to this carbon 2. This is carbon 3, carbon 1, and then carbon 4. We are still obeying the same molecular formula, which is C4H10. So carbon 1 is currently connected to carbon 2 just with 1 bond. So it means it can carry 3 other bonds, hydrogen, hydrogen, hydrogen. Carbon 2 currently is carrying 3 bonds. It is connected to carbon 1, it is connected to carbon 3, and it is also connected to carbon 4. So that means it has one more bond to carry, and that is where we have our hydrogen there. While carbon 3 currently is carrying one bond, so it can also carry 3 other bonds: hydrogen, hydrogen, hydrogen. So if we look at this now, our carbon 4 is currently carrying one bond, so it means it can carry 3 other bonds also. If you count, we have carbon 1, 2, 3, 4, and the hydrogen atoms that surround it, we have hydrogen starting from here: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that means we are still arriving at our molecular formula, which is C4H10. But this substance will not be referred to as butane because it is not what a straight chain hydrocarbon. So what will this one be called? Looking at this now, we have this here as a functional group. We have this here as a functional group. That functional group now is what changes the name of this substance from being called butane. So we have this functional group here, which is methyl. This is methyl, CH3. We have it on carbon 2. So when naming this substance now, we see carbon 1, 2, 3 as our parent chain. And since it is having 3 carbon compounds, you remember what we talked about, the carbon compound with 3, the hydrocarbon with 3 carbon compounds, we call it propane. So that makes this one our parent chain, which is what? A propane. Now, because we have a propane having this functional group on carbon 2, the name of this substance will no longer be what? Butane, but it will be called methyl propane. And the methyl needs to be what? Needs to be identified. We need to show the positioning of the methyl functional group. And that is why we refer to it as 2-methyl propane. 2-methyl propane. This is the name of this particular structure. So we can see now that it being C4H10, we can have it in more than one structural formula. C4H10, which is a straight chain hydrocarbon that is referred to as butane, can also have another isomer to be what? To be 2-methyl propane. That is about the 4th member series. Our N is 5. So we have it to be CnH2n plus 2. And that tells us that we have it to be what? C5H2 into bracket 5 plus 2. So that gives us C5H10 plus 2, and that gives us C5H12. So we can draw this particular thing here, which is called the pentane. The pentane, the straight chain hydrocarbon is called pentane. Let us draw it. Let's draw the chain. So it will look like this: carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. On this now we have carbon 1, 2, 3, 4, 5. So that tells us that we have our 5 carbon atoms. So like we have done in the past, let us put all of the hydrogen atoms. So we have this like this. So this is what we refer to as the pentane. That is the straight chain hydrocarbon. This is the straight chain hydrocarbon having 5 carbon compounds. And like we have done in the past, when we are talking about butane, a substance that has 4 carbon atoms and 10 hydrogen atoms, this one can also have isomers. So let us see another isomer of this particular compound, where we have it to be carbon, 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 and then here we have another carbon atom. We have another carbon atom here, so we can introduce all of this here: hydrogen, 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 and here hydrogen, 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 hydrogen. So if we look at this now, on our carbon 2, this is carbon 1, carbon 2, carbon 3, carbon 4. On our carbon 2, is where we have the functional group. So that makes it what? 2-methyl. 2-methyl. But this time around, on our parent chain, we have 4 carbon atoms. 1, 2, 3, 4. So it becomes 2-methyl butane. 2-methyl butane. That is going to be the name of this particular substance here. 2-methyl, methyl on carbon 2, and then butane as our parent chain. We can see that. If I move this one here, this methyl to carbon 3, automatically my numbering will change. That means I will no longer be starting my numbering from here to be my carbon 1. This becomes my carbon 1 because we must count to have the shortest words, the shortest number to the functional group. This is what I am saying. If I have this here, carbon 1, carbon 2, carbon 3, carbon 4, I have hydrogen, 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 and here I bring my carbon atom here. If I have it like this, looking at this now, you see that starting our numbering from here, carbon 1, 2, 3, 4. That is 1, 2, 3, 4. But in this position here, we have our methyl to be on second carbon atom. That is why we said it is 2-methyl butane, because we must count the parent chain to have the shortest possible number to the functional group. That is how we number. So for this one here, we will not be able to count this as our carbon 1 since our functional group is here. So our counting will start from here, carbon 1, carbon 2, carbon 3, and carbon 4. So that we arrive at the same structural formula name, which is going to still be what? 2-methyl butane. So that is about the 5th member series of the hydrocarbon. Now, this particular structure can have another isomer. Let me put the next isomer here. We could also see it looking like this. Carbon, 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 and carbon, carbon. Look at it now. We have 5 carbon atoms. 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5. Whichever way you want to look at it, you will still be arriving at the same thing. Hydrogen, hydrogen. Hydrogen, hydrogen, hydrogen. Hydrogen, hydrogen, hydrogen. Hydrogen, hydrogen, hydrogen. Looking at this substance now, we have, let's say this is our carbon 1, carbon 2, and carbon 3. That means on our carbon 2, we have one methyl functional group on carbon 2 above, and we have another methyl functional group on same carbon 2 below. So when we want to name this particular structure, if you look at it, it is still having the same molecular formula, which is C5H12. They are still following the same molecular formula, which is C5H12. But it will not be called a pentane, nor will it be called 2-methyl butane. In this particular structure, the parent chain is what? 3. 1, 2, 3. That tells us that it is what? A propane. It is a propane. Here we have one functional group, and here we have another functional group. So those 2 functional groups will now come up in the name of our substance. So the name of the substance is going to be, we have 2 methyl functional group on carbon 2, so it will be 2, 2 dimethyl. That is how it will be. 2 for this methyl here, and then 2 again for this methyl that is down here, and then our methyl is 2. That is why we'll be having di here. So 2, 2 dimethyl propane. That is going to be the name of our substance. 2, 2 dimethyl propane. So we can see now that for this particular compound, which is C5H12, we can have at least 3 isomers for this particular substance, which is what? The pentane, the 2-methyl butane, and the 2, 2 dimethyl propane. So, having talked about the first 5 members of the alkane series, everything we discussed can also be likened to other members of the alkane series. So now I want to look a bit into what the alkanes are, and we'll be using methane as our case study. So methane. Methane. What is methane? Methane is the first member of the alkane homologous series or family. It has a molecular formula of CH4. That is the molecular formula of the methane. Now, the methane is a component of a natural gas. It is a component of the natural gas which is gotten from the ground when it is mined or flared. Also, we say it is a component of petroleum gas. Methane is gotten or produced from the decomposition of plant matter in the absence of air. It is gotten from the decomposition of plant matter in the absence of air. Similarly, it is also gotten or released from swamps. Hence, its name as marsh gas. They also call it marsh gas. Yes, these are some things that we need to know about methane. Now, it is a component of the natural gas, and it is usually flared or mined from the ground. It is found in major parts of the world. We also say that it is a component of petroleum gas, and that this methane is produced from the decomposition of plant matter in the absence of air or oxygen, and then it is gotten or released also from the swamps, and that is why it is also called the marsh gas. So now that we have said a few things about the methane, let us see how methane is prepared in the laboratory. Laboratory preparation of methane. So how is methane prepared in the lab? Methane is prepared in the lab using what we refer to as the anhydrous sodium ethanoate. That we react sodium hydroxide or a particular alkali, majorly sodium hydroxide. We make use of alkali or a base. Let's say for this particular instance, we'll be making use of sodium hydroxide, reacting it with the anhydrous sodium ethanoate. When we react sodium ethanoate with sodium hydroxide using slaked lime or soda lime as our case study, we will be able to produce what we refer to as ethane. Let us see what that is. Sodium ethanoate reacting with sodium hydroxide. When sodium ethanoate reacts with sodium hydroxide, what we will be having is going to look like this. We'll be having our trioxocarbonate plus our methane. Let us look at it. We have sodium metanoate, anhydrous sodium metanoate reacting with soda lime. Okay, let me put that here. Soda lime. We have it when sodium hydroxide reacts with the sodium ethanoate. We have it giving us our sodium trioxocarbonate, and our methane, which is the gas, is what is given off solid form. This here also is solid, while this one is what? The gas. So that is what we'll be having that like. So let us just see a little diagram. Now here, let's assume what we have here is our sodium ethanoate, plus our sodium hydroxide plus our sodium hydroxide. So in this now, we will notice that when the reaction starts to occur, there is going to be film that is released from the reaction of the sodium ethanoate and the sodium hydroxide. Some gases will be released, and the gases then is released into water. Here we have water. We have H2O here, which is water. So we bubble the gas that is released from this setup here. We bubble the gas in water, and then there is going to be an upward delivery of what we know here to be our methane. What we'll be having here is going to be our methane. It is an upward delivery of methane. Which is our CH4. So this is basically what this substance will be looking like. When we have our sodium ethanoate reacted with sodium hydroxide from soda lime, we have it giving us sodium trioxocarbonate, and then our methane is being released. You can see the experimental setup of what the laboratory experiment is. So we can do something similar to this for subsequent alkane members. Perhaps we want to prepare other members of the alkane series. If we are using sodium ethanoate to get methane, and then the next member series will be using sodium also, but this time around it will not be ethanoate, it will be propanoate. And sodium propanoate will now be giving us what we refer to as the ethane. Sodium propanoate will give us sodium trioxocarbonate and ethane, while sodium butanoate, for example, will be reacted with sodium hydroxide. Similarly, it will be giving us sodium trioxocarbonate, and by the time we will be giving our substance here, it will be giving us the butanoate. Let us just see some chemical reactions to buttress our points. So if for this one we make use of sodium ethanoate to get our methane, for the next one we'll be using CH3 CH2 COONA. This is going to be, we refer to this one as sodium propanoate. You can see this one is having two carbon atoms, 1, 2. That was why it was ethanoate. This one is sodium ethanoate. So this one is having 3 carbon atoms, 1, 2, 3. That is why it is called sodium propanoate. Sodium propanoate in the presence of sodium hydroxide, like what we have here, will give us sodium trioxocarbonate, and then it will be giving us what we refer to as our C2H. If you look at the structural formula now, we find out that we have 3 carbon atoms here, 1, 2, 3, and on our product side we also have 3 carbon atoms, 1, 2, 3. And then our hydrogen atom on this side here, we have hydrogen here to be 3, and here we have it to be 5. Plus here we have 1 to be 6. So that is what we are having here now. Our hydrogen atom to be 6. So what we'll be having when we react sodium propanoate with sodium hydroxide, we will be getting sodium transocarbonate and the ethane. Similarly, when we have this CH3, CH2 into brackets 2COOH Na, that is we have it to be butanoate. This one is sodium butanoate. Sodium butanoate in the presence of sodium hydroxide will give us sodium transocarbonate. Similarly, sodium transocarbonate plus we have what? C3H8. So we can actually look at all of these structures, look at the chemical formulas, so we'll be able to understand what we are given. So what we are given here is methane. This is how to prepare methane in the laboratory, and to prepare ethane, that is the formula, the second equation. This one, the first equation is for methane, the second equation is for ethane, while the third one gives us that of the propane. So you can use the same method to actually get or prepare other chemical substances, other alkane members. Alright, now that we have talked about the laboratory preparation of some of these substances, let us go again to talk about the properties, the physical properties of methane. Physical properties of methane. Since methane is our case study, the physical properties of methane. Number one, methane is a colorless and odorless gas. Methane is a colorless and odorless gas. It does not produce any form of color or smell. So it is colorless and odorless. Number two, methane is less dense than air. Methane is less dense than air. That is another physical property of the methane. Number three, methane is okay, let me put it this way. Methane has no reaction on litmus. Methane has no reaction on litmus. That means there is no reaction on the two types of litmus papers that we have. It does not react with litmus paper. And lastly there, I said methane is slightly soluble. Methane is slightly soluble in water. Methane is slightly soluble in water. So those are majorly the four physical properties that we have for methane. So we have talked about the physical properties of the methane. Let us now look at the chemical properties of methane. And I'll be making use of this particular thing called the combustion. Combustion, that is one of the properties that I'll be making use of. I'll just talk about two of them, combustion and then displacement. So for combustion, let's consider this reaction. CXHY, which is a gas, plus X into bracket plus X plus Y over 4, X plus Y over 4, to give us Y over 2 H2O, which is also a gas, and then we have XCO2, which is also a gas. Now, let us use methane, which is CH4. Methane, the molecular formula of methane is CH4. So that means we have our carbon to be 1 and our hydrogen is 4. So when we have X for our carbon, we we put 1, and for our hydrogen we put 4. So that means we'll be having C1H, our Y, which is 4, which is a gas, plus our X is 1 plus Y, which is 4 over 4, and then our oxygen in gaseous form to give us our Y, which is 4 over 2, and then we have water here, plus our X, which is 1, CO2, which is the gas. So let us write out the formula, the equation now. CH4, we have that, CH4 plus, we have this one here, 1 plus 4 over 4. Okay, let me just put that so we don't get confused. 2 oxygen to give us 4 over 2 is going to be 4 over 2 here is going to give us 2. So 2H2O plus our carbon dioxide. So let me open this bracket now. So we have it to be what? 2 here. So that means when we react water with methane, what we'll be having, when we react oxygen with methane, methane gas in the presence of oxygen will give us water, and carbon dioxide will be what will be given off. Let's see the scenario where so this is about methane. We can do the same thing. This particular equation can be used for other alkane members. For example, let me just use this place to talk about that of ethane, where we have the formula to be C2H6. That means our carbon 1 will be 2 and our H is going to be 6. So from this now, we'll be having it to be C2H6 plus our, this one here, X, which is 2, plus our Y is 6 over 4, oxygen, to give us our Y is 6 over 2, and then we have water in gaseous form to give us our X, which is 2 carbon dioxide. So when we expand this now, we'll be having C2H6 plus 2 plus 6 over 4, which is 1 whole number 1 over 2. 1 whole number 1 over 2. So that means in this bracket here, I'm having 3 and half. So let me write that as 3 and half. 3 and half oxygen gas, to give me here 6 over 2 is 3 water molecule or steam plus my carbon dioxide, which is also in gaseous form. So for the chemical property of ethane, we'll be having ethane plus 3.5 molecules of oxygen to give us 3 molecules of water, and then we have 2 molecules of carbon dioxide. So that is the first chemical property of the methane. We said the chemical property for methane is going to be CH4 in gaseous form plus 2 molecules of oxygen, 2 molecules of oxygen gas will give us 2 molecules of water or steam, and then we have carbon dioxide. So that is the reaction for the combustion in the preparation of methane. And then number 2, I said we have displacement reaction. So for this displacement reaction, let me use chlorination for example. Chlorination. When methane reacts with chlorine, we will be having something that looks like this. Our methane plus chlorine will give us CH3 plus hydrogen chloride or hydrochloric acid. We have it CH3 plus 1 atom of the acid of the hydrogen component in methane will react with chlorine to give us this. And similarly, when we have ethane reacting with this, reacting with chlorine molecule, what we'll be having is CH2, Cl plus, we have CH2Cl plus HCl. So we can see the reactions that we can have in the chemical properties of methane. So quickly, let us look at the uses of methane. What is methane used for? Uses of methane. Number one, methane is used as a fuel. Is used as a fuel either by itself or when mixed with other substances. So we can use methane as fuel either by itself or when it is mixed with other substances. Also, the same methane can be used in the preparation. Methane can be used to make the following. It can be used in making hydrogen. You can use it to make carbon black. You can use it to make carbon disulfide. Alkane. You can use it to make trichloromethane. Trichloromethane, what you know as the chloroform, a major anesthetic. A major anesthetic. You can also use it to make hydrocyanic acid. Hydrocyanic acid. It can also be used to make tetrachloromethane. It can also be used to make tetrachloromethane, which is a major organic substance. A major organic solvent. So these are some of the uses of methane. This is as far as we can come for this particular episode of the tutorial. I want to believe that you would have learned one or two things from what we have talked about, talking about alkane as one of the homologous series that we have under the saturated or under the aliphatic hydrocarbons. So we have looked at the members of the alkane, we looked at the structural formulas, talking about their general molecular formula. We looked at different structural formulas, the isomers, how catenation is embedded in this substance. We looked at the laboratory preparations. We looked at the physical and the chemical properties as well as the uses of some of these substances. So I implore you to try as much as possible to watch this video again so you'll be able to get all that has been discussed in the tutorial. I want to encourage those of us that are yet to subscribe to our channel not to fail to subscribe to our channel. Subscribing to our channel has a whole lot of good to do you because you will get to benefit from everything that we discuss on this channel. Talking about biology topics, chemistry topics, so many questions that have been discussed and that will continue to be discussed on this channel. I want to plead with you to stay tuned to our channel as subsequent uploads will do you every good that you need to know. Thank you very much for subscribing to our channel and coming along with us. For those that are yet to subscribe, click on the subscribe button and also put on the notification button on the channel so you will get easily notified when we put up new contents on the channel. Thank you very much for coming along with us. It is a wrap for today.